Hello, Schools of Hope. This is Teacher Mark again here to do some more chemistry. We've been doing Organic 2, that's the Form 4 Organic, and we have been doing some stuff on polymers and soaps and detergents and vulcanization and so on. And what I'm going to do now is I'm just going to go through the questions which I sent you and your supervisors should have. And I'm going to hope that I can explain the little points. You can replay it several times so that you can understand it. But that's what I'm going to do. So I'm going to go through the questions. I'm going to show you the answers, and I'm going to try and explain why they are as they are. So now I'm just going to share the questions, and I'm going to write on them. So I'll sort of disappear a little bit. Okay. Firstly, these questions about polymers, and this is about ethene. And it's something that you should always know is that when we've got an alkene, that when we name its polymer, we just put poly in front of the ethene bit. Okay, that's it. So whatever the name of the alkene is, we just go poly and then the name of that alkene. Okay, so let's go for it. So when these add together, it says here, complete the equation to show the structure of 2 units in the polythene molecule. And all that happens, if you remember, is that one of the 2 bonds breaks and it joins it onto the next one. So what I would draw is there's the first pair of carbons. Here's the second pair of carbons. They're going to be joined here. And they're also going to join to other ones beyond them. And then I would put the hydrogens on like this. So it's really simple. We just join them together and we lose the double bonds. It's important that we not only join the 2 pairs together, this and this, but also we make a line like this. The name given to this is because these 2 add together to make the product. This is called addition polymerization. There are 2 types of polymerization you will remember now. One is addition and the other one is condensation, which we'll come across in just a moment. Here's a polymer and it's given us a following structure. Okay, now when you're looking at these, what you have to do is to try and work out what the monomer was if they're going to do a question like this. It says a sample of this polymer is found to have a molecular mass of 5194. In other words, the whole chain weighs 5194. Determine the number of monomers on the polymer. So what we have to do is we start anywhere on the polymer. Let's say I'm going to start here. And I go on along the chain until I find a similar part. And I say, oh, well, okay, that CH2 there is the same as that CH2 there. CH2, CH8, CH2, CHCN. So this was the monomer, okay, this bit here. And that was where the double bond was. So what I do is I say, okay, what does this weigh as a monomer? So I do the little calculation here. So I've got 1, 2, 3 carbons. So it's 3 times 12. And I've got 1, 2, 3 hydrogens. They weigh 1 each. And I've got a nitrogen, one of them, and they weigh 14 each. They give you the rams here. And that's going to equal 53, okay? So of the 2 marks, one of them is for just doing that. And then you go, okay, well, if the whole thing weighs 5194, then how many 53s are there in 5194? And it's 98. Do the calculator. And that's the second mark. So we start by working out what the monomer was. And you're just looking for a repeat unit. Okay, so I start anywhere. I could have started over here. It doesn't make any difference. I just go until I find the same thing again. So I start here and I go to there. Oh no, that's the next one. So it's this bit here. Okay. All right, next question. Here's a little bit of a polyester. Polystyrene polymer, and it asked me some questions about it. So draw the structure of the monomer, just the same as the one before. What I do is I start anywhere on the chain and I go until I find a similar unit, okay? So let's say I'm starting here. I go on, that's 1, that's 2. Oh, look, this one is like this one. So I stop here. So that the monomer was this, CH, C6H5 C H H, but it had a double bond. That's very horrible handwriting. My apologies. Let me make it a little bit better. Okay, so I just start anywhere and I go, okay, this carbon here has a hydrogen above it. It has C6H5. Then it's joined to another carbon, and that carbon has two hydrogens on it. And that was a double bond. Okay, that's important that you realize that if it's built like this, if it's an addition polymer, you just put the double bond in. Same sort of question again, exactly the same sort of question as the one before. I'll give you the answer to this one, but I won't necessarily do it for you because I think it's fairly straightforward. But you basically add up the mass of this. They tell you that the whole thing weighs 18096. I divide that by the mass of this, so the RMM of this goes down here. Try it yourself, but the answer should come out as 174. Okay. This sort of question, the next one, name a synthetic polyester. It's important that we realize two things. Firstly, it's synthetic, and secondly, it's polyester. It's best that you just remember one. Oop, that's not how you spell it. What a silly boy. So the best one, the one which is, oh, good heavens, I'm writing like an idiot. Sorry, this is my thumb. The best one to remember is pterylene, okay? There are other ones, like there is PET, and there is Dacron, if you know these ones. But I would remember pterylene. It's the most common of the ones that we do. Here's a protein, a bit of protein here. And what's important is that each one of these is an amino acid. So that's amino acid 1, 2, 3, 4 different amino acids. What is the name of the polymer linkage? Now, this is something to try and remember. This here is the same all the way down. This is the linkage, okay? The linkage is actually that bond. It is called an amide. Now, my students who find this very difficult to remember, you just have to remember that there are two types of fibers that they ask you about. There's the polyesters, like pterylene above, and then there's polyamides. This is a polyamide. Polyamides are things like nylon and so on. Still clothing materials, pterylene, nylon, but this is polyamide. And one of my students suggested that we just start spelling this a little bit differently, and we spell it anide. Now, it looks a little bit like amide there, but it reminds them that there's a nitrogen in it. Okay, so if you can spot that nitrogen, that's very, very useful. Okay, so try and remember the nitrogen is there, and that will really help you quite a bit. Okay, so anide is wrong. It's amide for this, but it's a question of spotting that the nitrogen makes it an amide. The structural formula of a man-made polymer. Now, amino acids are able to join many in a chain, slightly different, each one of them. But man-made ones are always of two different types. And the best way of doing it is just to draw a set of, let's say, 4 boxes. But what is important is that we've got one type of box, then a different one, then the same one again, then a different one, and so on. And how these work is this. What these start is with a C double bond O on the both ends of this one, and this one with N attached there. Okay, so we've got N here. This one, the hatched one, has got C double bond O, C double bond O. This one has got NH on both ends. Now, if you look at this, you'll find that this bit of it here is the same as this bit up here. But what's different is that we have alternating, one box with CO coming out of it, both ends, and one box with NH coming out of both ends. Okay, so that's what you're looking for. CO, NH, NH, CO, CO, NH, NH, and so on. Okay, that's what we're looking for. That's quite a difficult question to do. The 3 marks would be for 2 types of box. That's the first thing. That's 1 mark. The second thing is that they have to have some of these, whoops, sorry, some of these, let me just go back. Some of these groups, I'll just get rid of the H because it's easier, because then you'll see what we're talking about. So here's that, okay? Some of these, that's 1. And the third mark is for having CONH here and NHCO. CONH, NH, this would be CO, okay, because this is going to be another one of these ones alternating A, B, and so on. Okay. Detergents and soaps, these are fairly straightforward. What you've got to do is to be able to recognize them. Basically, the one that goes kuna there, this here is a, oh, why is this not writing? Really? Just a moment. Let's see if we can write somewhere else. Come on. Okay, I'll just have to talk about it. What we've got here is this one here is a soap. Okay, this one here, kuna. Some people think this is quite funny. This is here. Oh, why can't I write? Come on. I don't know. I do not understand why I cannot write. Anyway, this one here is a soap. This one here is a detergent. So soaps are COONA and detergents are SO4Na. Okay, so they've both got Na plus, but they're different. Kuna, as in Hakuna Matata, is a soap, and this one is a detergent. Which cleansing agent would be more suitable for washing in water containing magnesium sulfate? Well, any magnesium or calcium ion in water makes the water hard. And what happens is that soaps make a scum with hard water, okay? So not this one. So which cleansing agent would be suitable for washing in water containing this? It's this one here, it's B. And the reason for that is that A is a soap and soaps make scum, B is a detergent and detergents do not, okay? So you don't want your clothes to be, you wash all the dirt off your clothes and then it sticks to your clothes like a scum. You don't really want that. Probably don't want that. Okay, these are esters. Fats are, this is an ester, this is a fat here. You can always tell it because what it contains of is 3 bits attached to a stick here. Okay, so there's 3 long bits here, and then it's attached to this one set of 3 carbons here. When it reacts with sodium hydroxide, it makes this, and this is the soap. What type of compound has this formula? This is the sodium salt of an acid, of a fatty acid. We call them fatty acids. The sodium salt of a fatty acid, okay? And its use is soap. So if you wanted, you could say cleaning, because that would be fine. If you said its use is for cleaning, that would be absolutely fine. Let's see if we can write on this one. It's a bit boring not being able to write. No, how weird. Okay. Vulcanization is the addition of sulfur to rubber. Now, when rubber comes out of a tree, it's a liquid and it hardens, and we heat it up a little bit, and it becomes very sticky, fairly soft. And if you were to make tires for cars or for bicycles or whatever out of it, they would fall to pieces really quickly. So it needs to be stronger. If you have an eraser for rubbing out pencil, that is often just rubber. and it's quite soft. And if you had that on your tires on your bicycle, you would you would crash because it would wear out. So vulcanization is the addition of sulfur. The addition of sulfur, and it's when rubber is heated with sulfur, then it is vulcanized. Vulcan was the, I think, Roman god of fire. That's why they call it vulcanization. It's a little bit like volcano, but not quite, because that would be an O. So vulcanization is treating of rubber with sulfur and heat. And the two properties, just remember two, because there are many, many of them. The best thing is to think, okay, what's the difference between my rubber for rubbing out pencil and a lorry, a tire for a lorry? And one, it is very much harder and it is less flexible. It is still flexible, but it's not as flexible. It is also stronger, but that's it. Okay, so I hope those were useful. That's the end of that. I'll just stop sharing that. Remember, don't panic in an exam. Just take your time, read the question, underline the most important words, and then answer it. Okay, that's it.